Good afternoon, everybody. How's everyone doing? Yeah? Well, I hope you're having a good time here at Cloud Next. My name is Anka Cotwell, and I'm a developer advocate on the Google Maps API team. Today, I want to talk to you about how you can build with the Google Maps APIs for your use cases, for your industries, and how the Google Maps APIs fit together to provide great solutions. But before we get too far down that line, I actually want to take a quick trip down his memory lane. The Google Maps APIs is one of the first APIs that Google ever launched. And it happened actually a bit over 11 years ago. That's when we first launched the APIs. And the consumer product, the actual Google Maps website, hadn't launched much earlier than that. When we launched the website itself, the consumer product, it was the first time that we were transitioning paper maps to digital maps. Now, if you think back 11, 12 years ago, it's not that long ago, but this idea today of us using paper maps to get anywhere seems quite archaic. We've moved, our behaviors have changed substantially since then, where you'd pull up this big folding paper map, try and find your current location in some index, which will give you a page number maybe, or a grid number. You'd look it up. And then if you actually had to go somewhere, then you had to find your destination, and you had to route it yourself, right? That's, today, you would pretty much never do that. So as we started to build our Google Maps apps, we started with the base map, and we started to then add satellite imagery as well, make that available. Suddenly we were able to see the real world from space, effectively, what you can see from space. We added some elevation and terrain. But it was really when smartphones came along that we hit this inflection point of usability, right? Suddenly we had the world in our pocket. We had maps in our pockets. We were able to harness the power of these smartphones to include things like 3D buildings. We were actually able to direct people. They no longer needed to do things themselves to get places. And of course, places. I used that word just now. We were able to now start to bring semantic meaning to where you are or where you were going. You didn't have to think about your destination as an address. And that's immensely powerful, and I'll show you why. And in the world we live in today, we're very demanding of our mapping products, right? We expect that when we're routing somewhere, when we're heading to work, let's say, that if there is an incident on the road, if there are some roadworks, if there's an accident, if there's a slowdown, that we expect our apps will actually route us around there. Think about doing that in the paper days, right? You just kind of try and follow the route that you'd set out and hope that you made it on time, let alone try to dynamically route yourself around any issues that you came across. And we also have things like transit. We're starting to surface information about foot traffic as well. But the cool thing is, this was our story for the consumer app. We've actually followed the same story for our APIs, because we believe that developers are key to this story, that we're not the only ones that can build magical experiences with this kind of information. And it's the Google Maps APIs that are powering apps with this kind of information. And when you look at our suite of APIs, you can then start to see that those APIs can combine together to address some really interesting use cases. Fairly straightforward use cases like store locators, which you might think is like a pin on a map, but store locators can be so much more than that. Real estate agencies use store locators, or a version of store locators, to show their users what their dream homes are going to look like, what area they're going to be, how close the beach is. Put on satellite imagery for a beach house and you've sold the place very quickly. And then consider things like ride-sharing, right? Today, or ride-hailing, in the old days, we would stand on the side of the street, stick out our hand, hope that a taxi or a cab went past and was available, and we would then be on our way. Today, we pull out a phone, right? We're able to then say, hey, find me my closest taxi. It will find a driver for you. But if you think about the other side of the experience, where you actually tell it your destination, you don't have to type in a full address anymore. You don't have to swipe your map to get there. You type in a few characters, and it auto-completes what your destination is. These apps are smart enough to remember sort of what your most popular destinations are, where you came from, where you're going to. And the Maps APIs are enabling this great user experience. They're enabling this transition or this transformation in user behaviors. So we look at those use cases, and we start to see these industries that these use cases can have impact and have positive impact on. We just talked about transportation and logistics, right? Think about insurance. We're able to see the kinds of foot traffic that you get in certain areas. So if you park your car out on the streets in a busy area, that insurance premium could be higher than if you happen to have a garage in the same area. And these industries, new industries, are sprouting up all the time. If I had given this talk a year ago, I would not have included gaming on this slide. Not because gaming is a new industry, but in the last 9 months, we have seen Pokemon Go explode, right? And it's because that team, that brilliant team at Niantic, were able to work out how to make location-based gaming or real-world gaming relevant to all these users. And one of the data sources that they used was our Google Maps APIs. So you can see that these APIs are really powering big things. Which brings me to today's topic, which is the Maps API layers. I'm going to present to you 4 layers for developing on the Google Maps APIs. And the way I'm going to present this to you is talk to you about use cases and industries that we're able to address with each of these. Now think of this stack as a developer's stack, where you start at the top, there's minimal code required from your side. But as we go further down the stack, we get increased customizability and control over how we present our experience. So let's start with delegation. And delegation really is about saying, you know what? I believe I need some sort of mapping, some sort of location intelligence in my app, but I'm going to let somebody else handle it for me. I'm going to let Google handle it for me. For whatever reason, it could be for development constraint reasons, or it might just not be a core piece of functionality in your app. And on Android, we have this mechanism called intents, where you can, from one app, intent out to another app. And you can provide some additional context so that it can initialize that other app to whatever it is that you're looking for. So if you look at these intents here, the first thing we're doing is loading a map of San Francisco. So this is where, in your app, you might want to send your users, you want to provide them a map of some sort, centered around San Francisco, and in 3 lines of code, you can say, hey, give me that latitude, longitude, which is on line 1. We create that URI, create an intent, passing that URI in, and then we set this package that says, hey, send it off to maps, and then start activity. 4 lines of code. We can also do it for things like actual searches. So maybe we don't know the actual destination we want to go. We're just doing some discovery. So here, we put in the lat long that we talked about at the start, but we also added a query for restaurants. We can kick off navigation, because many apps kind of want to direct, sort of point users to their destination, but not necessarily control that navigation experience. We can do that. And here, we're going to Taronga Zoo in Australia. We can even fire up Street View. Now, we've talked about Android here, but you can achieve the same thing on iOS. And on iOS, a similar thing is called, the comparable feature is called URL scheme. So if you look at the demo on the left, we're just hitting launch, and it's actually firing up the browser. Now, what I'm going to show you is the iOS code to achieve this. And the reason that there's more code on iOS is, 1, it's Objective-C, so it's a little bit more verbose. But 2, that first if condition, that block, is checking whether the user has the Google Maps app installed. If it does, it's going to use it. So on Android, you can be fairly confident that users are going to have Google Maps. On iOS, it's sort of a personal preference. Some users will have it, many users will have it, some users won't. And so a piece of code like this, in that first if block, we're able to check, hey, do you have the app? If so, fire up Google Maps. If not, just fall back to the browser, and we're able to accomplish the same things. So that's simple. That's that first layer, delegation. We're not really doing anything inside of our apps. We're letting Google handle it for us. Layer 2 of this stack is incorporation, where we want to put a little bit of mapping functionality in, but again, it's fairly light functionality. We just want a simple map. And here, on a website, you could use the static maps API. The cool thing about the static maps API is it's just a URL that you pass in, and you put in the parameters that you need. So we've said the center is a particular location. We specify the zoom levels. We can even specify a resolution and our API key. And this will return back as an image. So the nice thing about this is there's no JavaScript involved. You just put an image tag with this URL around it, and you're away. We give you some customization options as well. So as you can see from the 3 screenshots, we've applied a custom style. On the very left-hand side, it's a monochrome style. On the second slide, we've used satellite imagery. And on the third one, we've actually drawn a line. That there's a blue line in the middle that's sort of navigating you from, I think in this case, it's my hotel room to my office in Mountain View. But if you want to go beyond static maps, if you want to make it interactive, if you don't want just a picture, we have the embed API, and that allows you to embed a map onto your site. Right? It'll put it in a nice little a frame there, and you're doing it by specifying an iframe, and you can do things like, again, provide directions or even do street view. So we're just starting to touch the surface of some of the mapping functionality we can do. Now, for the next piece of incorporation, I'm going to look at a specific use case, and that's location sharing. Now, it may not be obvious to everybody, but location sharing is actually something we do very often. And it's useful in many, many contexts. Right? It might be as simple as just letting your family member know that you're running late because you're stuck in traffic. You might location share, I'm stuck in traffic, I'm here. Right? It could be that you're saying, I need to get somewhere. So going back to our ride-sharing application, where we're trying to find a taxi for us, we usually share our current location so we can get picked up there. Now, that might seem like a lot of work, but we've tried to make it really, really easy. Easy for you as developers, and easy for your users. And there's 2 things I'm going to talk about here. The first one is the place picker. And the place picker is really, it's a UI widget that you can just drop into your app, and it provides this fantastic user experience. I'm going to kick off the animation. But you have a map in the middle. You can drag it around. You can drop it on a pin. And then below that map, we actually have a list of locations. So in case you don't want to interact with the map, you can just pull up the list of locations and identify which place you're at. There's also a search box at the top, so you can type in which location you're at. But the nice thing is, we provide an out-of-the-box user experience that's very familiar to users and is powered by the Google Maps APIs. So you know it's going to be accurate, and you can trust it. It's an easy way to have your users share their location, because they can just pick what's there. The nice thing is, it requires very little code. So on Android, we have 2 parts to this code. The first part is we're going to start off the place picker activity. We're going to say, hey, go ahead and show the place picker. We create one of these place picker intent builders. And then we call this method start activity for result. And the reason we call that method is because we want to know when the user has finished selecting a place that process has finished, and it can pass us the result. So once the user goes and interacts with this widget, we get a callback. We just confirm that we've come back because of the place picker, and then we get the place that the user selected. Couldn't be easier. Right? And suddenly, location sharing, which can be a hugely complex affair, you imagine trying to code an experience like this, dropping a map in, having scrollable lists, using GPS or Wi-Fi to actually populate those lists in a meaningful way. It's not necessarily trivial code, but we've trivialized it by providing this out-of-the-box widget. And we have parity on iOS as well. So on iOS, again, it's a similar amount of code. We're going to instantiate a GMS place picker config. We're going to go ahead and kick it off so it displays the place picker. And when we get the callback, we're just going to pull that place. You see that last if condition there. We're just going to pull the place out of it. In this case, we're getting the place names. That's it. That's how easy it is to share location. Another example where our ride-sharing application might be useful is something called autocomplete. So if you think about ride-sharing, when we want to get picked up, we always have a place to go. So if you think about your ride-sharing app, you look up your destination. You know, I'm not a fan of the keyboard on mobile devices, so I don't like to type a lot. Right? It's not easy to do. It's easy to make typos and so on. autocomplete here is powered by the same magic that powers Google Search and Google Maps in terms of its sort of recognizing what your intent is with few characters, right? So an autocomplete widget makes a lot of sense whenever you need to ask the user for an address of any sort, right? They can look by name, they can look by its address. If they really wanted, they could probably look by latitude, longitude as well, but really humans don't work in that way. Anyways, on iOS, having an autocomplete widget is similar, the amount of code is similar to the place picker. We are creating one of these autocomplete view controllers, we're firing it off, we get a callback at the bottom there with the place that the user selected, and we're able to pull the name out. On Android, again, the code looks very similar. We have an intent for the place autocomplete. We go ahead and call start activity for result, and we get the result back. So location sharing becomes simple, yet very refined as a user experience. So that's some examples of incorporation. But I know most of the developers I work with are like, I really want to go deeper. I want to be able to write some code myself and produce some magic. And that's really what integration, layer 3, is about. It's about saying, hey, you know what? This Maps API, I want to use it, I want the data from it, I want to customize it, I want to really make it my own, I want to personalize it. And the use case where this becomes immensely useful is when you want to visualize a map, right? So let me show you this particular demo here. Well, it's a screenshot. So Google I/O is our other large conference for developers, and we have that annually. And in 2016, Google I/O for the first time was actually held at our campus in Mountain View. Now, Mountain View is actually quite far from the main San Francisco city, and we knew that there would be a lot of people that would be traveling from all over the world to this conference. So what we did is that we organized buses to pick up these attendees from various hotels in various parts of San Francisco City, and actually all around the Bay Area. And these buses would then take these attendees to the conference and back. But we thought, you know what would be great is if we could show a demonstration of our Google Maps APIs and display on a dashboard our bus tracker. So we built a bus tracker. And if you look at this layer 3 of integration, what we're doing here is that we've grabbed the usual standard JS Maps API v3, but we've custom styled it. We've put custom markers on there to represent buses and represent hotels. We're using polygons to draw the path that the buses are taking. And then we have some just standard HTML elements that sit on top that tell you where these buses are going, which stops, which hotels it's going to be stopping at. But we also added time estimates. So if you look at the top of the boxes, it says leaving in, next in, and then on the left-hand side, it tells you time estimates of how long it's going to take to get to those spots. And we're using the Directions API to get those time estimates. But I'll talk about the Directions API a little bit later. But here is an example of integration where we've really changed the visualization of how these maps are. Now, if you're interested in an example like this, we actually open sourced this only a couple of weeks ago. So if you go to github.com/Google Maps, look for Transport Tracker, you can see the full source code for this and use it for your purposes as well. Now, we've had custom styling on maps for the web version, for the JS API, for a number of years. And one of the biggest requests that we've had from developers is when is it coming to Android and iOS? So it was only a couple of months ago that we were thrilled to be able to launch custom styling for Android and iOS. And as you can see from the animated screenshot here, it works exactly as you'd expect. You can change the style at runtime, right? And you don't need to tear the map down and bring it back up. You just call set style, and it goes ahead and applies it. So examples of where this could be useful is if you're building a fitness app or some sort of driving app or navigation app. If you change the style to reflect the time of day, so as it hits evening time, we're able to switch into a night mode theme and vice versa. The other really cool thing about the way we did custom styling is that you specify your styles using a JSON file, right? And we provided a styling wizard. So if you just do a Google search for Google Maps styling wizard, you'll get to a site where you can see a map, and you get a bunch of really friendly sliders and radio buttons where you can custom style your map for you, and it can export a JSON file. Now, the nice thing about that JSON file is it's the same format whether you want to use custom styling on the web, on Android, or on iOS, a single file. And you can either ship that JSON file on your app or website, or you can host it yourself, and then at runtime dynamically pull down whatever is your current style. So we give you full flexibility there. It's not just about changing colors. You can actually turn on or off landmarks. You can change the density of labels. So maybe you don't care for points of interest in your app, or you don't need to show as many roads. We have sliders that enable you to turn that up or down. There's a ton of flexibility here. And this is the type of integration and that attention to detail in your apps that makes your apps shine and stand out. So that's how we look at the map as a whole. I want to switch gears and talk a little bit about the camera. So if you see here, this is downtown Los Angeles. We've just got an Android app. We've focused on downtown Los Angeles. And this is a style of map that you're used to seeing. In fact, you can see the heritage of paper maps coming through here. But we're on a digital device. And realistically, if you're, let's say, building a real estate app and you want to show people what their next dream home could look like, showing them some perspective of that map is a much better user experience than necessarily showing it from top down. Now, having this sort of depth, 3D buildings, really nicely zoomed in and having tilt, that's not necessarily applicable for every use case, but you can certainly see having this sort of rich visualization in certain types of apps, like the real estate app, add a lot of value to your users. And pulling this sort of thing off is incredibly simple. We have, when you specify a new camera position on Android, you have to create one of these camera position objects. And we have a couple of methods on there. So some of these values you should recognize. Things like target, which is the latitude and longitude where you want to focus on. Things like zoom, which is how far in you are. But then bearing allows you to turn the camera basically like a compass to see which direction you're facing. And tilt is the thing that comes in and puts some depth on it. So it brings that camera really closer down to the surface, if you choose. Just adding those extra parameters, and they're just numeric values, adds so much more to the experience of your app. And the other thing that I recommend is that as you change your camera position, don't just snap the camera to place. Don't move the camera. Use APIs like this one called Animate Camera. And what Animate Camera does is it works out the difference between where the camera is looking at now compared to where it needs to be, and it gracefully animates the camera there in a nice, smooth flow. Right? So if your users are going through, let's say, houses, we'll continue with that example, in a list, and they're selecting the next one, don't just jump the camera there. Move them. Help them retain that context of where they're moving to and where they came from. On iOS, we achieve the same thing. Again, with iOS, in Objective-C, we use a GMS camera position object instead. We have at the bottom of those parameters, you can see bearing. And instead of tilt, on iOS, it's called viewing angle, but means exactly the same thing. And as you can see with this demo here, we have the same sort of depth, 3D buildings, and so on. Let's have a look at another use case, a store locator. And as I mentioned earlier, store locators are much more than just a marker on a map. Right? You can make them very rich and useful beyond just one particular point. So here's what I did. I was a little bit naive, and I searched for Italian restaurants in Rome. And I managed to get quite a few results here. It shouldn't be a surprise to anybody. Just dropping markers where all these Italian restaurants are, this is not a great user experience. Right? Imagine trying to make sense of this, like, hey, I'm visiting Rome, and like, where should I go and eat? There's really not much to be gained from here. A better way to present this is with something that we call marker clustering. And this is what marker clustering looks like. You'll see there's some clusters there, and as we zoom in, those clusters split apart, and we're able to see more concentrations of these markers. But as we zoom out and they start to overlap, we coalesce them. They group up into these clusters. And visually, we put a count on there so that your user can kind of see that this is an important cluster or not. So we actually change the size of the cluster, we put numbers around it, and so on. This is part of an open source library, and I'll tell you about that library in a second. So you can customize all of this. But let me show you how much code is required to implement marker clustering in your apps. The first thing you need to do is tell your Gradle in your Gradle configuration, specify that you want to use the Android Maps utils library. The second thing you need to do is look at your data class. And in our case, our data class is going to be our list of restaurants, right? So we'll have restaurants with name and lat long and whatever else. Maybe it'll be rating, cost, and any number of things. But all we need to do is add this one, implement this interface, this one extra method called getPosition, which just returns its latitude, longitude. Once we have that done, we create or instantiate one of these cluster managers, and we tell our map that anytime the camera changes or the user clicks on the map, that the map should let the cluster manager know about it. And that's how, when we interact with the map, those clusters are like coalescing and forming new ones or splitting up. And then step 4, we go ahead and tell our cluster manager that here are all our restaurants. I didn't put the step 5 on there, but the step 5 is that you should go ahead and remove any code that you have to add markers onto the map or take markers out of the map, because the cluster manager is going to do that for you. So in these sort of 10 to 15 lines of code, we've suddenly implemented cluster marker clustering, and we've probably reduced the amount of code that we had from before we started. So great user experience with minimal effort from a development standpoint. Instead of clusters, we can also do heat maps. And the heat map implementation looks similar to clusters, where we generate these heat maps depending on zoom levels. And so as we zoom in more and more, you start to see the heat map sort of start to split apart, or when we zoom out, it combines into larger ones. Now, I mentioned this was an open source library, so if you don't like my alarming colors, you can definitely change that. The API itself allows you to change that as well, but it's very easy to do. Again, the implementation for this is trivial. It's the same library that we use. We add that interface we have on our data items. We then instantiate a heat map tile provider. This is the thing that's going to generate the tiles, depending on zoom levels and lat longs. On that step 2, I just want you to point out the .data. That's where we add our restaurants, right? It's just that one line. It's going to manage it for us. And then step 3, we add a tile overlay, and we add it to the map itself. That's it. That's the whole code for the heat map implementation. So when it comes to doing deep integration, really look at things like custom styling. Personalize your maps. Look at ways that you can uniquely present whatever data it is that you want to present on a map. Don't overwhelm your users. Use the visual metaphors where possible. All right. So we've gotten to the point where we've done some integration, but I've had developers come and tell me, but Anchor, I just want the raw data. You know what? I will manage everything. I want to do it. I want to control everything. I want to be the orchestrator of all of this. So let's look at an example in fleet and asset tracking. Right? Typically with fleet and asset tracking, we have a number of vehicles. We need to do some deliveries. We need to optimize around that. There's a number of APIs that can really help here. The first is the Directions API. Now, the Directions API is a web service, right? So you can call it on any platform, but we do recommend that you proxy it, any of our web services, through a server rather than consume them directly on mobile. And if you want to know more about why that is, we had a great talk today called the Development Best Practices for Google Maps Web Services. It will be up on YouTube within a day or so please do look that up. We cover some great best practices there. Back to the Directions API. The great thing about a Directions API is, one, it returns you this nice JSON output. It tells you step-by-step directions on how to get somewhere. It tells you exact latitude and longitudes on how to get your users to places. You can specify different travel modes, whether you're driving. So in the use case we were talking about, the asset tracker, it might be a driving delivery that we're doing, or it might be cycling. We could do that too. But at the bottom there, you'll see duration. We can actually give you travel times of how long it's going to take for you to complete this journey. And that's immensely powerful. And very, very useful for things like our ride-sharing service that we talked about earlier, or even any delivery service that we're going to do. Now, this information is powered by the same engine that powers Google Maps, that does navigation, that provides real-time directions. We can take this one step further. Let's say our business isn't actually asking for this information right now, but they care about a delivery time at 3 a.m. tomorrow morning. We have predictive travel times for that. So what we've done is, over time, we've built these hugely complicated models of traffic for all over the world. We've put it through our machine learning algorithms and developed new machine learned models out of that. And we're applying it to understand traffic conditions, not just now, but when they'll be at various times of the week, at various points in the world. And of course, if you know that your vehicle is going to be on a road, you should consider using the Roads API. Something that actually surprises a lot of folks is when they're told that the GPS on their phones, regardless of which phone you have, it's actually not that accurate, right? There are times, unless there's a perfect line of sight, it's often not very accurate. It gives you a range of values. And so even though you're driving along a straight road, you could get a GPS response up here, down there, across there. I mean, overall, you're going straight, and you could kind of start to see that pattern. But the actual data that it gives you is not necessarily straight. So I'm going to say, computer, enhance. And we're going to look at this data that we captured. So this is a car that was traveling around this park and around some buildings. And what you can see here is, apparently, this car cut across a park, drove through the park, and further down, actually drove through a building as well. Now, you can judge my driving however you want, but I did not do that. The Roads API can help us eliminate these sorts of problems, noisy GPS. So what we did is we then took those exact same points, put them through the Roads API, and we ended up with the green line. And the Roads API is intelligent enough to know that, hey, look, I know that this vehicle was on a road throughout this journey. I'm going to look at this data, and I'm going to interpolate what is actually happening here. And so it will snap those points to the road, but where you've got like curved roads and things as well, it will actually smooth that path out. It will add new points to that list of latitude, longitude, so that when you plot it, it looks nice and smooth rather than a jagged polygon. So the Roads API is immensely useful. Let's look at local discovery as a use case. Now, in the case of local discovery, we just want to learn about other places around a particular location. So I'm from Sydney, Australia, and so when I visit San Francisco, one of the things that I tend to do is, hey, which restaurants should I go and check out, which bars, what attractions there are. And one of the APIs where we provide this information in is the Places API. And the Places API is something that we provide as a web service, as well as a native API on Android and iOS. And I'm going to cover both. With the Places API, you can get lots of information about a place. Because if you think about a latitude and longitude, it's a point on Earth. It doesn't make a lot of sense when you're in a multi-storied building. In fact, if you're in a multi-storied building like the Moscone Center today, you're not even going to get a GPS location, because we don't have direct line of sight with the satellites. We're indoors. We're also not we're not just at a latitude and longitude. We have to consider height. And this is where Places can help. Places is able to tell you the difference between being on floor 3 of this building versus floor 2. If you're in a shopping mall, you can actually tell whether you're at a cafe or a hairdresser, even if they're somewhat close by. And the way it does this is by using information like latitude and longitudes, Bluetooth beacons, Wi-Fi access points, and more, as well as assisted GPS, which is triangulating cell phone tower information as well. But the great thing is, once you have a place, it has a ton of semantic information. So here's a response that we get from the JSON request. I've highlighted a couple of things. I'm just going to talk through those. The first one is formatted address. This is actually a big challenge to solve as a developer, because if you're a delivery or a logistics company, especially a global one, the way addresses are formatted in different parts of the world varies drastically. Right? Some places have something called a zip code, some places have a postcode, some use numbers, some use letters, some put the state before the zip code, some put them after. And getting that right can mean the difference between your customer receiving their package on time, or either not getting it, or getting it late, or not at all, right? And the Places API is able to format this for you exactly to the destination. So we handle that complexity for you. We give you the latitude and longitude. We also give you the name. But you're also able to get some additional metadata. You can get photos of the place. You can get information like ratings of what the users have said about it. You can get the establishment type. Is it a school? Is it a library? Is it a place of worship? Is it a bar? So there's tons of great information. And if you use the Places API in your apps, the thing to remember is to hold on to this thing at the bottom called the place ID, which is a unique identifier for every place in the world. Because once you have that place ID, you can retrieve any place details you want. So it's a great way to do a local discovery app. Use the Places API, do a place search, and find what types of places there are around. And you can filter by establishment types on the web servers. For the Android and iOS API, we purpose-built the Places API for specific use cases. So rather than searching anywhere in the world, we wanted to make this a lot more contextual. So this is very much about the places around you. So on Android, we call it get current place, or current place with callback on iOS. And I'm going to show you a quick demo. What happens is when we use the sensors on a phone, we give you a list of places that the user is likely to be at and some values. Now, you don't need to see these values specifically clearly. Just know that these likelihood values are going to be between 0 and 1. And the closer it is to 1, the more confident we are that the user is at that place. So here's a demo. We're driving along the 101. And you'll see that the list of places that we're getting back is changing. They're moving up and down. And the likelihood is changing as well as we move along that route. And that's where you can really use this Places API to determine where a user is. And so in that location sharing example we talked about earlier, I showed you the place picker. The get current place is the API that powers the place picker. So if you want to orchestrate it yourself, you can do that. It's a bit more work for you, but certainly gives you all the data and information you need to make a good user decision. Now, we've just talked about a number of web services today. They're really, really useful in different contexts. We looked at some use cases, we looked at some solutions. Now, you might find that you need to use these web services on different platforms. And even though web services can be consumed on any platform, we've tried to make that development easier for you. We've built a number of client libraries, and we've built them for Go, for Python, for Node.js, and for Java. And they're open sourced, they're available at github.com/Google Maps. And not only do they make it easier to consume these web services in those languages, but we've also put in some additional features. Right? We've made authentication really, really easy. We've added exponential backoff for when you have any failures. We've also made it so that you can call that API synchronously or asynchronously, depending on whatever style of development you're using. So it's worth checking these out. So that brings me to the close of this presentation. We've talked about these 4 layers of development: delegation, incorporation, integration, and orchestration. We've looked at them in the context of various use cases to build great solutions. Everything I've talked about today is actually available on developers.google.com/maps. It's where all of our developer documentation lives, and it links out to things like our GitHub repository as well. So please do check it out. I want to thank you for coming today. I'm going to open it up for Q&A right now. Thank you. Questions? If you do have a question, if you can just come to the microphone. We have one right in the middle here. That would be great.
Ankur, great talk. You gave a lot of perspective and functionalities that you're offering around basically location-based services, navigation, point location. And of course, Google Maps also has a very rich collection of satellite imagery. So have you been thinking to take some of that data out and put it through an API?
Just the imagery itself?
Yeah, just the imagery itself. Yeah.
We don't really do that in a big way today. The best sort of in the Maps API specifically, you can get maps and you just change the map style to an image. But if you're looking for map tiles specifically, it's not something that we make readily available in this context. Yeah. If you use some of the custom styling stuff, so it depends on exactly what your use case is. The closest you could get is that if you define a custom style and turn off all the labels and things for roads, and then set the map type to satellite, you could get a fairly you could get a good sort of satellite view. But it really depends on what you're doing there. That might not be sufficient. Well, I'm going to be here on the side if anybody has any follow-up questions. The other thing I also should mention is that tomorrow we've got a number of great talks on the Maps APIs. We're going to be looking at topics on specific verticals like gaming. We're going to be looking at ride-sharing. We have some interesting talks on geolocation as well, and location intelligence. So I hope you're able to join us. And for those of you that are watching on YouTube, you can certainly find those talks. We'll be publishing them on the Geo Developers blog and on YouTube as well. So thank you very much, everybody. I hope you enjoy the rest of the conference.